And for example 6, we're going to be using f of x again and g of x. Let's take a look at example 6. This is a little bit more advanced. It says evaluate f of g of 3 all divided by f plus g of 9. Alrighty. Well, this is kind of complicated, right? But we can break it down and solve it no problem using the order of operations. So what I went ahead and did is I rewrote the top because f of g of 3 can be rewritten this way. And what I'm showing you is that we are going to be doing order of operations. When you're doing function composition, that's considered parentheses. In fact, I should go ahead and copy that up here as well. So we want to do parentheses before anything, right? So when we have a function inside of a function, let's do that. So what's g of 3? Well, let's go to the graph here. G of 3 is equal to 6, so I'm going to replace that with 6. Again, I need to use arrows more. I realize that, okay? And so we did that. We did what's in parentheses. Now, do we do f of 6 now? Well, that's not actually technically. We could actually, yes, we could. But I'm going to go ahead and do the bottom part. F plus 9. I'm going to break that down. F plus g of 9 is the same as f of 9 plus g of 9. Okay? So again, for that, the order doesn't matter. I kind of wish I would have done what's in parentheses first. Okay, yes, I did actually do what's in. Well, actually, yeah, I guess once you break it down, they're all the same, right? Like once you break this down, each one of these acts is exactly the same thing: f of 6, f of 9, and g of 9. So we can replace them at the same time. So I guess they are kind of like parentheses. Okay, so let's figure out what f of 6 and f of 9 are. Well, f of 6 is going to be 2. F of 9 is going to be 5. So f of 6 is going to be replaced with 2, and f of 9 will be replaced with 5. Now we just need to figure out g of 9, and g of 9 is equal to negative 6. So that will be replaced with negative 6. And we've done everything that's in parentheses or evaluate the function. So now what do we have? We have division and addition on the bottom. Now the bottom, don't be confused here. The bottom is technically also, you could put it in a pair of brackets, in a set of brackets, right? So you want to take care of the bottom first before you divide, because it's its own unit. It's a sum. So 5 plus negative 6 is negative 1, and then after we take care of the bottom, then we will divide. So we got 2 divided by negative 1. The d in PEMDAS is negative 2, and that's going to be our final answer for this somewhat complicated function composition problem. That's it for this example. If you have any other questions about it, let me know.